so today we're gonna get ready for our fourth lab, I believe, and this is the Theodolite, or the angle measurement lab. So far we have measured horizontal distances, we have measured elevation changes, and now we're going to measure the internal and thus external angles of any closed traverse, or open, really. Okay, so this is called a theodolite. It used to be known as a transit, but theodolite's the more modern word, the one we choose to use. It is expensive material, expensive equipment. Be very, very careful with it. It seems pretty sturdy, and it is, but it can, not that it'll break, but it'll lose its very delicate calibration, so watch out. Which is why I'm demonstrating how you unbox this, right? So here it goes, very nicely cushioned. As you can see, most of this box right here is actually just padding, but here it is. Okay. So I don't have the tripod here. We will soon demonstrate how to use this, but first I wanted to show you what are the different parts of this. In this box we have the theodolite itself. You also have a plumb bob, which will be very important to this, something to cover it from the rain, not that you should be out in the rain, and I don't even know what this is. Oh yeah, a little screwdriver, in case things start falling apart. Hopefully, I've never had to use it, so don't worry about that part. Okay, so we're going to set this up on top of the tripod the same way we did with the auto level, but this one requires even more precision in leveling it. So for that reason, it has two bubbles really that you have to watch out for or take care of. The first one is right here. So this one is going to be adjusted, this bullseye, in the same way that we did the auto level. You're gonna set this, first you're gonna set your tripod really nicely. If you don't remember how to do that, go watch that video. Get that ready, set this on top of it. Make sure that the nail is perfectly on top of, that the plumb bob's pointing to the middle of the nail. And then you're going to use these adjustment screws to level it off. However, once it looks level and you can see that the bubble is in the middle, and it's clearly not gonna happen right now, it'll happen outside, then you actually have to pay attention to this one. This one offers you a lot more precision. So even though it looks to be in the center, you will see that this one's off. So when that happens, you're gonna need to rotate your, right now this is locked. So you're gonna need to unlock it by using one of the locking screws, which depending on what angle you're looking at it from, these two can get confused one with the other, but this is the one that you need. You either lock its horizontal rotation or you release it, okay? And it can rotate. And the idea is that you're going to rotate this to be aligned with each one of the screws, and then move that screw a tiny bit so that it goes to the center, then move it a little bit more, adjust tiny bits, move it a little bit more, adjust it tiny bits, till it is in every single position, both in the middle of the bullseye and in the middle of this one as well. Okay, so this is the precise, more fine leveling indicator. Okay. So now we have our scope over here. It also gets locked, so you need to release it with this one right here. No, wait, that's not the one, this one. So this activity right here is important. It can actually go 360, and we're gonna talk about something called plunging the scope here in a second. But imagine that this is set up, and I'm gonna actually set it up on top. It's a little low right now. Okay, so let's say it is on top of the tripod. This is where you would be sighting something. Here you have your general sight just to help you point the right direction. You look through this, try to find where there's gonna be someone standing with a range rod or a pole of some kind. You point, then you are going to lock the horizontal. Once you got it on your sight, you wanna lock the horizontal rotation, not location. And again, because this turns, it gets confusing. But let's say now, you know, it can't move because you want it solidly in place. And you are going to point, and here's a trick. If you're trying to measure angles, and there's gonna be two people holding the range rods, and you wanna measure this distance, chances are those distances, because the range rod is on the nail, you want to point to the most bottom part of that range rod, because probability of it being a slightly off will increase as you get higher, okay? Because, you know, a slight tilt in the range rod will be large degrees of difference in your measurement. So you're gonna point to the very, very bottom of the range rod. There is a cross in here. And then once you get to that point, and by the way, there are within these different screws, a coarse adjustment, which is the larger one, and a fine adjustment one. So once you lock it in position, then you can play with the fine adjustment screws to make sure that it is really crisp, and so that your cross is right at the bottom where you can still see where the range rod comes out of, as well as right in the middle of the range rod. So you're gonna lock the scope, not with this one, but with this one. Okay, so let's say here, and then you see I lock, this one locks it as well as this one, and this one adjusts really finely. It's kind of like moving the scope so little you can't see it, but you can notice it once you're looking through. And once you are happy with where you are, I'm gonna show you what you're gonna do with the screen over here, okay? And you're gonna have to be measuring, let's say you have two people here. The idea is that you would point at this person, zero it out, then turn to this other range rod. Let's say you have, you know, 84 degrees and something, you're gonna have degrees, minutes, seconds, you're gonna write it down, and then you're gonna look back, and there's two different methods of looking back that we will talk about, but the idea is that you're gonna kind of check your work, okay? I'm trying to see what else I need to mention about this here. There is an adjustment here at in the eyepiece, again, locking and then fine adjustment. Oh, and there is also, I almost forgot, this one over here allows you to, and of course can't see anything, through here. Is this the one that has that? Yes. With this one right here, it has a little bit of a scope that allows you to see down, and the idea is that you should be able to see the nail in the middle. So this is another, if you don't have a plumb bob, this is a optical plumb bob. I was trying to say visual, but that's not the right word. And that helps also with precision. With angles particularly, if you're just slightly off the nail, if you don't point to the bottom, those little degrees, I mean, like with everything, precision matters, but here it is so delicate that you will see that you might do your best throughout the lab and find that at the end your error is too large. Okay, so really, really pay close attention to the details. Okay, so let's look at the screen now. So here is the screen of the Theodolite. By the way, it has the same screen on both sides because you're actually gonna have to do this number, this rotation, while you're taking angles, because there's something called plunging the scope, and I'm gonna show you what it is. The idea is that if I take this angle and I measure from here to here, when I'm done and I wanna return the value and check my work, it's kind of like taking it twice and then taking an average. To make sure I get rid of any minor bias from, you know, maybe the ground moving a little bit or something changing slightly, we're gonna do this. You're going to release the scope, which I always do the wrong knob. You're going to do this, and then you're going to do this. Okay, and by doing that, basically, if there's any, actually it has more to do with the internal calibration of this. If there's anything that's slightly off, at least it will cancel itself out by doing the same measurement, but with the whole setup backwards. Does that make sense? Okay, that's why there is a screen on both sides, but it's the same thing, it'll show the same thing. So let's look at the buttons here. So first of all, we're gonna turn it on, okay? So immediately you will see that it assumed when I started it for the first time, it's 0. Immediately it moved to 1 degree because I touched it. But here's the parts that matter. Here, this is just light in case it's a little dark where you are. Okay, there's some things you won't worry too much about, like this one, because you can also measure. So here you have the angles, but you can also do vertical measurements, but we're not going to use this for that. Okay, so RL means right left, because it depends if you, like, maybe I want to measure, you see right now it's at 0, almost 0 there. Actually, I can 0 set it. So I'm going to lock it in place by saying, okay, let's say that I'm pointing to whoever I was pointing to, lock it. But now I want that place to be 0. So I'm gonna click here where it says 0 set. So it makes that angle 0. Actually, because I touched it, let me try that again. You know, there's 1 second there, that's fine. Now, let's say that I wanna measure the distance between this point and some point over there. Oh, which by the way, this is pointing at me, so that should have been there from the beginning. Okay, 0. Okay, so now I'm going to release and I'm gonna move it, but if you see what happened here is it started measuring from 360 down to 0. And that just means I have to do math in my head, and that's not a good idea. So I can click RL, and now it starts measuring from 0 to 360 instead of the other way around. So once I've locked my view into whatever I'm pointing to, again, I'm gonna lock it in place, and I'm gonna say write that down, okay? So what I'm gonna do, and I'll show you how hold works here in a second, but hold is so that you can move your measurement. So we talked about 2 different methods. One of the methods involves, so now that we've measured this and we're about to go look back at our first point, we're gonna plunge the scope, okay? But that measurement would change. So I'm gonna hold that measurement, you see, and it makes it turn on and off. Release this, and I'm gonna turn it around and look at the same thing, okay? And when I've found it, I am going to, I can release the hold, okay? But make sure that you are also locking it in place, okay? So now I can release the hold, and I can release this and measure back. And hold on, this thing got weird. It doesn't help that I'm not in the actual, oh, I guess I moved it too fast. Okay, there we go. And hopefully when I look back, I'll hit 0, but more than likely I won't. But the error, the difference is an important thing because we're gonna teach you what to do with that information. So, okay, so one of the methods is look, 0, measure, plunge scope and lock, and then go back to 0. But the other one, which is actually my personal preferred one, but you can use, I think, depending on your, just make sure you read your lab instructions, is to actually do one where you double it. So you look over here, you plunge, I'll do it here, okay. So let me go through that process real quick, unless you wanna, no, okay. Okay, so let's say this is my first point. I'm gonna 0 set. Now I'm gonna release. I'm gonna look over here. I'm going to lock it in place. Okay. I am going to plunge my scope. I'm gonna hold first. Plunge scope. Turn it around. Look at the same position. Lock it in place. And then I am actually going to go back to my original point here. And at this point, I'm going to release the hold. And then I'm going to measure back here, in essence, doubling it. And then you're going to divide it by 2. So if the angle was, let's say, perfectly 21 degrees, the second time it should give me 42. But chances are it's going to be 42 and a half. So then 42 and a half divided by 2 gives you an average of these 2 measurements, which tends to be more precise than just the one. And you have to do, a little bit of math, but it's not too bad. But in any case, don't forget to plunge the scope. And now you know RL switches from 0 to 360 or vice versa. 0 set to mark the beginning of your measurements, and hold depending on the method that you want to use. And that's basically all there is to it, except for it's actually really, really important that you're very, very careful, and that's what takes time, especially as you're learning. The setup of the tripod, the setup of this on top of the tripod, and then the very specific measurement and holding and writing down and all that stuff. Okay, so let's get out there. So I just set up the tripod on top of the nail. So when we do angles, we need to set up on top of the nail. Everything looks good. I'm actually centered in the bullseye, but remember how I told you there's more precision involved here. So we have a second level over here. And if I know it's a little hard to see, but right now there's a large bubble and it's over there, even though the bullseye looks to be in the middle. So the way you're going to do the fine leveling is you're going to look at this. This is important. So you see how I basically have this centered around 2 of these screws. So now I'm going to, it's already centered, so the movements are going to be very, very small, but and it's going to be hard to see, but basically I'm going to move this direction a tiny bit at a time, and you need to wait because the bubble kind of very slowly creeps. So if you do it really fast, it'll just hit the other side. So till it's in the middle. So I'm gonna stop because I moved it a lot, and I'm gonna wait for it to settle. I actually overdid it, so I'm gonna go back a little bit, wait till it's perfectly centered, almost, a little more. All right, that looks pretty good. It's right in the center. So I'm not done. I'm actually going to now turn it and align it with the other 2 screws over here and see if it's in the center. It is not. So now I'm gonna use these 2, one or the other, to try to get it centered, but again, the movements will be very small. That one's not helping, and do check that your overall bubble isn't completely off. That could be bad. Okay, so I'm topped out over here. I can't go any further, so I can use the other one to help me move it. Okay, it's starting to move towards the middle. Slowly, it's already moving, so I'm gonna stop messing with it. Okay, looks pretty good. And it continues to look really good over here. And one more time, we're gonna do this 3 times. And this is for every setup, and you're gonna have to set up over, if you're gonna measure all the angles over the number of corners, the exact same number of places you need to, of corners you need to measure angles. This one's already centered as well. Did we do it 3 times? Hold on, did I miss one? Oh, no, yeah, okay. Good. I'm good. I forgot. So yeah, and I come check the last one. It came right into the middle, which means I am perfect right now. Great. So now I'm starting. I have 2 points here that I'm gonna be looking at, if you wouldn't mind pointing. They're both on top of a nail, so I wanna know the angle between this direction. And given that this is A, I'm gonna say that's B and C. I'm gonna start with this being 0, and then I'm gonna measure from 0 to 360 and figure out how many degrees, minutes, and seconds are from here to there. Okay, so with that in mind, everything's level. I'm happy with my setup. I am going to start by using this one to kind of generally try to find the Philadelphia rod. Once I do that, I'll look at the scope. I will, of course, oh, did I already? Yeah, never mind. Okay, there we go. This one's really blurry, so I'm gonna try to focus a little bit, and you see it is moving too much, so I can start by, once I detect it, I can lock the horizontal rotation. Did I get that right? No. Okay, there. And I can move the scope up and down, try to find it. There it is. And you can't see what I'm seeing, but I'm pointing at the very, very bottom. And I'm trying to aim at the center of the rod. So, and that's where my colleague should be standing. Now, she's actually pretty close, so it's still pretty blurry, but I'm gonna try to get it as focused as possible. I'm not dead centered, but I don't wanna move it manually. So I already locked it, and that's where I start using the fine adjustment screw, which is the smaller one, to move right and left. Okay, let's say I'm happy there. I'm also pointing all the way down, and I'm gonna lock the vertical direction in place over here. And then I can use the fine adjustment screw to move up and down, make sure that I'm as low as possible, but within, within reason. I also don't want to be looking at grass. Okay, so I'm pretty happy. I'm going to turn it on now. Everything's locked in place. Okay, I'm going to 0 set. Okay, click on the 0 set. You've seen that already. Great. And now I'm going to unlock the horizontal and the vertical, really. And I'm going to go point at the other point. Now it's measuring right now from 360 down to 0. I don't like that, so I click on RL. RL, okay? So now I'm gonna point, I'm gonna do a general direction, I'm gonna lock it. Oh, there, lock it. do fine adjustment. I'm gonna unlock this for a second so I can move it up and down to try to find, oh, there we go. Oh, of course, I'm using the wrong one. It's kind of trippy because you're turning it around sometimes, so it looks different. Okay, moving, it's right in the center. I'm right down below, like at the very bottom of it right now. I've locked it in place using fine adjustment to get exactly where I want to be. Focusing, making sure it's great. Wonderful. Okay, so now, let's say right here, it's 33 degrees, 39 minutes and 05 seconds. So I am going to, in one of the methods, and again, make sure that you are properly reading the instructions because we change them a little every year. I am actually going to hold this number, click on the hold button. That's great. Our battery failed. Great. Okay, I'm gonna show you what you would do. This is why you charge the battery right before. So what I would do is now I'm gonna plunge the scope. So release this, do this, release the horizontal, and aim back over here. And if you're using the method where you go back to 0, you look here, find it, and then move back. Or if you're doing the double one, you really would then keep the hold, look at this position, find it again, release the hold, and then go here, and it will double the amount. So if it was 33, it would become 66 and some. And write that down as the double so that then you can divide it by 2 and get an average. Okay, but the idea is that one way or another, you're looking, measuring, plunge, hold, and either looking back and then back this direction or just going one. It really depends on what method is preferred, okay, or most commonly used, or what the instructions say. But that's really all there is to it, except make sure, again, you're very precise, very careful, finding not only where the pole is, but the center of it and the very bottom of it. That helps with precision because poles tend to, you know, at the top be a little off. So, of course, the two people over there are going to be holding it, and with the level, try to keep it as steady and as vertical as possible to help you with your measurements. When you are done and you have that written all down, at that point, you're gonna remove this, move to the next location, and then so I measure this. Next point, I would stand over there. They would move, one would be there, one would be there. And then from here, I would choose, you can choose which is your 0. I mean, it's all the same from here to here, from here to here. But let's say, do the 0, measure here, go back to check, and then write that down. Then stand there and do the same thing, okay? You have to stand on all of the different points in your closed traverse to get all the internal angles and make sure they all check out. And after that, you're gonna look at your notebook, you're gonna do some calculations, you're gonna make some adjustments, and you're gonna make sure that you're not too far off. There is a percentage by which you can be off, and if it's more than that, you're gonna have to do it again, okay? So let's get to it.